Okay, I'm going to start my talk. Hopefully it won't take very long. It's just wanted to give you a bit of an idea of how we're evolving around working with secrets. So there's a lot of work been going on. The main aim of what we've been doing is around self-service deployment. So I'm already doing the work, or you've already got the ability to manage your configuration and versions of the stuff you deploy. And we also have like auditing and approval processes around what we're deploying via the PRs in our pull requests, approvals and pull requests. And we introduced not that long ago Field Marshal as well, so you've got the ability to push your releases out. So got a lot of stuff there that helps you do self-service. The remaining bottleneck in that, as I think many of you will be aware, is how we manage our secrets. So up until almost today, you always had to go through one of the platform engineers to get secrets. The reason this has happened is because basically around security concerns, we want to make sure that our secrets are managed appropriately. So rather than opening them up to the world for everything, we wanted to make sure we had granular access controls and make sure we got audits of who's reading as well as writing our secrets. So you may have heard us talk about Vault before. We've been looking at it for quite a long time. We've been starting to get familiar with it and installing it and getting it working. Basically, Vault is a secret management store. We have got it set up to authenticate against Active Directory, which means we've got the user management part of it. We've got policies defined to allow granular access to our secrets, both reading and writing, so we've got the authorization side of it. The secrets are stored in an encrypted format, so we've got a bit of security around there. There's a couple of features that it gives. The main one I'm going to focus on is the key value store. So there's nothing clever about that, it's just a key value store, but it's stored in a way that implements the other parts there. And then there's some more functionality that we want to take on, so things like dynamic secrets, the idea that you can just ask for a password to connect to our production Mongo databases, do some work, and then those credentials expire at some point after you're finished. So we have that auditability trace without preventing people from doing what they need to do. So I'm going to talk about how we want to use Vault today and how we're going to work with our secrets. And this is about opening it up to everyone in engineering to manage the secrets really as much as we can. And this is an evolving process. It's not going to stay exactly as we're doing. I'm showing you now. Hopefully we can improve it and tidy up and make use of some of the other features of Vault as we go along. Basically, the way we're using it today is kind of taking what we had, which was very similar to the app config stuff, and translating that to Vault, which basically means we store the secrets in the key value store in Vault, and we inject them into the containers at startup time or deployment time as environment variables. So it's very similar to how it works now. That might evolve in the future, but I want to try and minimise the amount of change in one go and keep it as simple as we can while we're still working with it. So I'm going to now just quickly go through basically what that means to you. So I have actually put together a guide on Confluence, working with application secrets, which you can read through. That's basically what I'm going to follow right now, just to give you an overview. So the first thing I'm going to talk about is authentication. So Vault is it's a server-based store, but there's a command line interface as well, which is what I'm going to be using. You can download it from the official HashiCorp website, install it on your machine, and then it just gives you a command line thing to use, basically. Can you all see that? I can make it a bit bigger. Okay. So I mentioned authentication. So first thing I'm going to do Vault login. I'm telling it basically I want to log in using LDAP. LDAP is the protocol used to talk to Active Directory. So this is basically using your Windows username and password to log in. So my Windows username is david.shepherd. It'll ask me for my password, which I'll try and remember, which I think I just typed wrong. Oh no, I didn't. And now I'm authenticated, and that's kind of authenticated for a period of time on my client. So I won't have to do that every time I want to do commands. So we've added all the engineers, or I believe, to an Active Directory group that gives the permissions to do what I'm showing you now. So you should be able to do this as of today. We're going to be focusing with the key value store for now. There's loads of stuff in Vault, which I'm not going to talk about, but feel free to read about it and play around with it, and we'll roll more stuff out as we go. So the key value store is literally as a key value store. There's nothing clever about it. So we can list some secrets. I'm going to look at what secrets I've got stored against this key. So secrets is the name of the key value store, green, and then dub solution store. So this is a list of secrets stored for the solution store in dub green, basically. And that's just a list of the keys. If we wanted to read a specific one, we can do Vault read, and then the name of the court. Help if I didn't copy the whole thing. Sorry. So Vault read. Oh, I've still got duplication there. This is what happens when I try to shortcut it. Vault read, and then the name of the key that I want to read, and I get back something that doesn't work. Let's try again. There we go. I get back a value, and that's the secret there. The rest of it is around leasing, which becomes a bit more important for dynamic variables, but I'm not going to go into detail there. Yes?
Is that the base 64 encoded secret?
No, that is a plain text.
Plain text.
Yeah. So everything stored in Vault is plain text. The Kubernetes base 64 encoding is handled elsewhere, so you don't need to worry about that. Shout if I'm going a bit quick, if there's anything you want me to go into more detail about. So we've read a secret. Okay, that's very easy. Yeah, so we can go now and query any of the secrets here. So, for example, if I wanted to get the connection string from Mongo, I could go and query that, and then I could use it. The other part of this is writing our secrets. So we want to be able to store and update our secrets. So I'm going to go into detail about the convention and the naming convention in a minute. But basically, we're going to write a secret. I'm going to write a secret called secret green test service API key, and I'm going to set the value to ABCDEFGH blah 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 blah. Okay, and it says it's written, and then I can now read that value back, and I get the same value back. Nothing clever about this. It's nice and straightforward. It's just getting to learn the commands. And if I make a mistake, I can delete that API key as well. So we've got the ability to read, we've got the ability to write, we've got the ability to delete, list them, etc. I've authenticated against myself, and we do audit this, so we do have a track of who's doing what. So if you start messing around and deleting stuff you shouldn't be doing, deleting or whatever, we do follow it up, and that's part of the security work. But we want to give the freedom out to you guys as much as possible.
Can you recover if I delete it? Nope. No, you can't recover.
Pressure.
With great power comes great responsibility.
We do back up, but we don't really want to have to restore from a backup if we can avoid it, because that's a blunt tool for a device. So just be aware of what you're doing. Really shouldn't be deleting stuff. It's usually if you've created it with the wrong key and you've only just created it and you want to get rid of it again.
Speaking of blunt tools, if you do delete one, there will be a blunt tool.
Was that sorry? I thought that was a question. Okay, so now how do we use these secrets? I want to talk about that side of things. So one of the benefits of moving to Vault is that we can reduce the. I'm trying to think what I'm trying to say. So we want to make sure that we're injecting the secrets into our containers. So I'll show you how to define that in a second. What we want to also use Vault for is to try and deduplicate stuff. So at the moment, things like API keys, we define it for every single service that requires that API key. So we might have, I think the example I'm going to show you is we have here the retirement solution service in dub green requires the pension projection API key. Okay, we want to avoid defining that both against this service and against the pension projection service. So what we can do is reference different locations in Vault to do it. So this is an example of, this is app config. For those of, most of you probably have seen this already. This is where we define our configuration for applications. We've added a section into each environment to say secrets, and this is a list of the environment variable names that we want to inject the secrets into, and then the value is the location in Vault. So, for example, that one there, I can go and say Vault read, and that's the API key in green for the pension projection. Okay, don't tell anyone it's a secret. Hello?
Question.
Yeah.
So obviously something is telling app configs to look at Vault at that point rather than...
So the deployment mechanism, what the field marshal is doing, is going to look at this config. It's then going to read this list here, and then for each of these, it's going to go and pull the value from Vault from that.
Is it pattern matching, or is it just going to try every single value and see if it exists in Vault? Or is it just?
It's just those three. Those three there are going to be retrieved from Vault. That's why they're separate. So these are your standard configs. These are your secret configs, and that's just makes it easier for us to say where that they need to come from Vault rather than taking the value explicitly. The reason we define them explicitly is we don't want to just inject all our secrets into all our containers. That would by only injecting what you need, it's reducing your attack surface. And secondly, it means you can deduplicate things. You don't have to know exactly where things are. So in this case, pension projection API key for this service is looking in this location. Okay, just the null there. And if I look at the pension projection configuration, I've got the API key there, but it's also set to null. So we're doing a bit of convention over configuration here in order to try and make things consistent. So when you specify null, it'll assume it belongs to that service, and it'll look in a known location, which is secret / in this case green / pension projection, and then the name of the environment variable. Which, if we go back and look at this one, that's what this is. That's saying I'm going to use the API key from the pension projection. So the secrets live with the service that they belong to rather than the clients, because I know of 2 services that use this API key to talk to the pension projection, so that it makes sense to live with the pension projection service, and then we just reference it. So the idea is that for things that are owned by this service, we don't define where they are. We use it by convention. For things that belong to something else, we do that, and that convention is all documented in here. So that's what this section is talking about here. So don't worry if you don't follow what I'm saying right now. Read the documentation and then give one of us a shout, and we'll try and do this. So that's basically working with them. In terms of where we are today, this is working. We've got a number of services. The ones I've just shown you do use Vault secrets. I'm just in the process of migrating everything else, so within the next week we should have everything moved there. The easy way to tell is basically if an app config has a secret section, it'll be using Vault. If it doesn't, then it won't. Okay, so if you're not sure, then give us a shout. The other thing is the migration process is it's just an automated script I've written, so we're going to push everything in. So we won't be deduplicating in the first instance, but we will be tidying up as the next step and as we go along. So you may find that we are still duplicating key values in some places, but we are going to hopefully tidy that up to make it a bit simpler. That's basically all I wanted to show you. So does anyone have any questions on that? Yes.
At the minute, the test frameworks are specifying those API keys, for example. So even if you have the secrets involved, we still have the source that the test framework is using them in plain text and config. Would we be able to integrate with this Vault?
Yes. So we're trying to, because Vault can become very integral to our services. We're trying to take it a little step at a time, which is why we're injecting the values at this point. I know Graham a few months ago demoed a node module that would talk to Vault directly and pull them out, and that's kind of where we want to go. Is we tell a service, or in this case a test framework, only how to access Vault. We don't tell it what it can access in Vault, and then it requests the secrets it needs when it needs them, and that becomes a lot more powerful because you then stop reducing the need to actually have to pull the secrets out in order to to do stuff, you can start letting Vault just handle the secrets, and we can have our applications use them without us necessarily having to know what they are. So yes, it would be great to move to that. Anything else?
I just wanted to add to that the reason we're taking this approach at the moment is at the moment the secrets only need to be available at deploy time. So Vault only needs to be working at deploy time. As we move to a model where the application is talking directly to it when it needs it, that will be basically switched to having a service that's got to be up all the time. So as we learn Vault, we're taking this kind of, if it was unavailable, what would it affect? And if it only stops a deployment, that's kind of acceptable at the moment. I think actually if we could get the services, the tests to read directly from Vault, that would actually be quite a nice interim stage, because, all right, we don't want to affect the tests, but the test not working is probably more acceptable than the service being dead entirely. So that might be one of the first things we suggest moving to kind of the library read. Good.
Okay, thank you very much.